Good morning, everyone, and welcome to today's class. Well, this is lecture number 25 on work, power, and energy. We are done with work and energy. What we are going to do today is we'll start with the next heading of this chapter, which is known as power. Now, I'm sure that all of you know what is power. Can anyone throw some light on it? What do we understand by the term power? What is power? Someone tells you the power of this motor is 17 kilowatt, the power of this engine is 50 kilowatt. What do we understand by the term power? We use a term known as horsepower as well to define the power of engines. The horsepower of this engine is this much, the horsepower of that engine is this much. What do you understand by the term power? Can anyone tell me from the class, online class? I hope everyone is there in the online class. Rahul, Ajay, Siri, Deepak, Tejasvi, Karthik, Swati, Harshita, Vahini, Veronica. Anyone can tell me what is the meaning of the word power, or what do we understand by power? Karthik says rate of doing work. Satvika says ability to do something. That is not power, Satvika. That is ability to do work is energy. That is not power. Harshita says amount of energy converted per unit time. Okay, even that is correct. So basically, if I Suren, yes, work done divided by time taken, yes, that is also, we can call that as power as well. Absolutely correct. So in simple terms, whatever you have understood about power is correct. You might have read this term power in your ninth standard, and you would have done it like this: rate at which work is done, work or energy. So if you are spending energy, the rate at which energy is spent, or the rate at which work is done, is known as power. So if you are doing work, the rate at which you are doing work with respect to time is power. If you are spending some energy, if something is giving you energy, heater is giving you energy, heat energy, the rate at which you are getting that energy, or that heater is spending that energy, is known as power. What type of quantity is power? Work is scalar, so power is also a scalar quantity. We all understand this. Then, what is the SI unit of power? Work divided by time. SI unit of work is joule, time is second. So joule per second. You can also call it watt. 1 joule per second is equal to 1 watt. So basically, if you are spending, or if you are doing work, 1 joule of work in 1 second, your power would be 1 watt. Very simple. There is no complication in this term because it is very simple to understand. Whatever we have done in standard 9 is still valid here. Whatever you have done in standard 9 is always valid. Whatever you have learned in your lower classes is always valid. While you are getting older, getting more mature, everything is valid. The only thing is, sometimes in your lower standards, we don't define the terms very correctly just to make them very simple. Power is very simple term and we have defined it correctly there. Rate at which work is done or energy spent is power. Scalar quantity SI unit is joule per second or watt. I'll give you a minute to write this down. This is what we mean by power. So please note this down. Power is the rate at which work is done. If you have any doubts, please raise your hands. I don't think that would create any problem here. It's a very simple term that you must be able to understand. Okay, I hope you have noted this down. It is quite simple. Rate at which work is done. Now, when you talk about power, we can have or we can think of power as two types. It should not be two types. It would be like we can imagine it in two ways. What are the two ways in which I can imagine my power? The first way in which I can imagine my power is known as instantaneous power. Instantaneous power. And the other one is average power. Instantaneous power and average power. Now, instantaneous power is denoted by the letter P. Average power is denoted by P with a dabba. You must recognize this dabba. You must be able to recognize this symbol. We have used it before as well. We have used it for average speed, average velocity, average acceleration. The same dabba we are using here. Then we have instantaneous power. Now, here one thing you have to understand. When we talk about work, when we talk about work done by a body, I'd already told you that work done by a body is never instantaneous. How much work the body is doing at this moment, it is not defined. Work is always defined over a period of time. How much work you have done in 2 minutes? You can't say how much work you have done at 1 second because work is not instantaneous. Work is always defined over an interval of time, and that is why I had used delta W for work done. Delta tells me that it is always over an instant of time. That's why I use delta for work. I hope you remember this. Can I have some reason that we remember this, sir? That work done by a body is always defined over an interval of time and it is never instantaneous work. But when we come to power, power can be defined instantaneously. Now, what do you mean by instantaneous power? We'll come to that. First, let us try to understand the easier term, which all of you probably know, and that is your average power. What is average power? Anyone? What is average power? What is average power? If I try to define the average power, and I would write it like this, P with a dabba, obviously it is also a scalar quantity. Power is a scalar quantity. If I define this average power, how would I define this average power? Anyone? You can use your previous knowledge. That will be very valid here. Previous knowledge of average speed, average velocity, average acceleration, that will come in handy over here. So, Bacho, can you tell me what would be average power? Average power. What would be average power? No one? I hope I am audible and visible to all of you. What would be average power? No one knows this? Average power? You know this? I know that you know this. Can you tell me what is average power? No one would like to say anything? Okay. Average power is total work that I have done over an interval of time. Total work divided by total time. Surendra is saying delta W upon delta T. That is absolutely correct. When I say delta W, it is the total work. When I say delta T, it is the time in which that work is done. That is exactly what average power means. Average power is total work divided by total time. It's as simple as that. Nothing wrong in it. Total work divided by total time. Now to find out total work, I can write it like this. It will be integral of f dot dr, where dr being the displacement, divided by total time. I can write it like this, integral of dt. If I want to write it in a very fancy way, I can write total work will be integral of dt. dt meaning say small word. If I integrate dt, I will get total work. So this is one fancy way of writing the same thing. Average power W1, average power is total work divided by total time. I can write it like delta W by delta T. Delta W standing for total work, delta T standing for total time. I can write this as f dot dr ka integral divided by integral of dt. Do we understand this? Can I have some raise hand that we understand this? I'll give you a minute to note this down. I hope all of you have noted this. Now, why I'm saying that this term is already known to you, I'll just give you a small example. When I said this term is already known to you, it is similar to what we had done previously. For example, if I say average speed, average speed was total distance divided by total time. So you can write it as delta L, where L is the distance, or you can write it as L. You can write it as L total distance divided by total time. If I have to write average velocity, it will be equal to total displacement divided by total time. As you can see, all these words, all this are similar. So this is delta R vector divided by delta T. Everything is similar. I hope you are getting this. So average power or average speed or average velocity or average acceleration, where I have used the term average, they all mean the same thing. Total divided by total time. Total work divided by total time. Total distance divided by total time. Total displacement divided by total time. That is how you calculate average. Now, coming to, I hope you are writing everything. Coming to what I mean by instantaneous power. Now, I have given you all these three things so that you are able to understand what is instantaneous power. Now, I'll define instantaneous power by the letter P. Now, remember what we discussed in this chapter 1 when we talked about instantaneous speed, instantaneous velocity, instantaneous acceleration. When we talked about instantaneous velocity, it was velocity at particular instant. Speed at particular instant. Acceleration at particular instant. Those were instantaneous velocity, instantaneous speed, and instantaneous acceleration. And I also told you that if I'm saying velocity, I'm referring to instantaneous velocity. If I am saying speed, what is my speed? I am referring to my instantaneous speed. If I'm referring to acceleration, if I'm saying this, my acceleration is 5 meter per second square, I am referring to instantaneous acceleration on similar grounds. When I say the power that the rate at which work is done by this machine is 5 kilowatt, I am basically talking about its instantaneous power. So what is instantaneous power? Instantaneous power, just like instantaneous velocity or speed or acceleration, is power at that instant. At this time, right now, what is the power? After 5 seconds, what will be the power? That will be the instantaneous power after 5 seconds. How do I find the value of this instantaneous power? To find the value of this instantaneous power, what do I need to do? I need to make this time interval, this time very short. How do I make this time very short? I put the limit of this time tending towards 0. Now, instead of writing it so big, I can simply write it as dw small work divided by dt. This becomes my instantaneous power. You can understand the difference between average power and instantaneous power. In average power, I have delta W divided by delta T. Delta T is large instant. In instantaneous power, I have made the limit of delta T tending towards 0. That means I am talking about at any instant. Do we understand this? Can I have some raised hand that we understand these? No, Vahini, we cannot use delta here. It is dw by dt. It is instantaneous power. I cannot use delta. Delta means large change. D means small change. So instantaneous power is dw by dt. Now, if I can go some further, dw, small amount of work, dw, small amount of work is f dot dr. I am not putting the integral sign because integral sign will give me total work. I am talking about a very small work. So this is f dot dr divided by dt. Now, if I look closely at this yellow one, dr by dt, rate of change of position vector, rate of change of position vector, rate of change of position vector, I can write this entire thing as f dot v, where v is your instantaneous velocity or simply velocity. So now I have some really cool ways of writing power. I can write power as dw by dt, instantaneous power I'm talking about, or I can write it as f dot dr divided by dt. dr divided by dt is rate of change of position vector with time. That becomes my instantaneous velocity. So I have f dot v. That becomes my instantaneous power. Am I clear with everyone? Do we all understand this? Can I have some raised hands? All students in the class, can I have some raised hands? Everyone has understood this, starting from Satvika, Krishna, Karthik, Shashank, Judges, Charita, Ajay, Satya. Are you all there and do we understand what is being discussed in the class? Great. I will give you a minute to note this down. Instantaneous power is power at any instant, and that is how we define it. Remember, instantaneous power is almost same as instantaneous velocity, instantaneous speed, or instantaneous acceleration. They all mean power, velocity, speed, or acceleration at any particular instant. Whenever it say power, you are referring to instantaneous power. Whenever you say velocity, you are referring to instantaneous velocity. Whenever you say acceleration, you are referring to instantaneous acceleration. I'll give you a minute. If you have any doubts, you can ask. I hope you have written this instantaneous power dw by dt f dot v, a very important formula that you must remember. What next? Next comes relation between relation between what? P and P dabba. P means instantaneous power. P dabba means average power. What is the relation? What is the relation? What can be the relation? Okay, let us try to formulate a relation. And please note it is a very important thing that you must remember. P dabba is delta W divided by delta T. Now this delta W is integral of dW divided by, I can write it as integral of dt as well. Total time is the integral of dt. I've already explained. Now this integral of dw. Now look at this orange term. dw by dt is p. I'm going to write it here on in green. P is dw by dt. So I can write dw as, small amount of work as p dt. Do we all understand this? I can write dw as p into dt. Yes or no? Can I have some raise hand that you understand this? I can write dw as p into dt. I am going to substitute this thing in our equation. So what do I get? It will be integral of p dt divided by integral of dt. And this is a very, very good way of writing this and understanding this, that your average power is integral of instantaneous power into dt divided by integral of dt. In fact, the function that we are using here, and this is for math students, this function that we are using here is known as the average function. This function is known as average function. Whenever we have to find the average of anything, this is how we find out the average of anything. I'll elaborate on that. So it is integral of p dt divided by integral of dt. I hope that one is clear. Then I can further elaborate it like this. I can write it as integral of f dot v. F dot v is p. F dot v into dt divided by integral of dt. I hope it is clear to all of you. Raised hands will give me more confidence that we have understood all the different ways in which I can write average power and instantaneous power. And we have also understood the relation between P, instantaneous power, and delta and P dabba. P dabba meaning average power. Average power P dabba is integral of P dt divided by integral of dt, and this integral of something dt divided by integral of something dt is known as average function. And I'll tell you how it is this average. I'll give you a minute to write it down. If you have any doubts, you can raise it now. I hope you have noted this down. If you have noted this down, let me give you some important notes. This is all for math students. Average function. I use this term average function. What is this averaging function? It's a mathematical term. For example, if I have a function x, average value of f over time, if I have to find the average value of f can be any function. I have to find this average value of f over time. T could be something else. T could be time, T could be distance, T could be anything. Most often or not, it is either time or distance. That is what that is required for us in physics. We'll just concentrate on that. If I have to find, if I have a function, any function, it could be any function, any function, any function, any function. If I have to find the average value of any function over t or x, see how do I write it? I will write it as f dabba standing for average, and I will simply find out this integral f dt divided by integral of dt. That is the average value of f over time. Physics and maths are beautiful together. Beauty of nature. This is the average value of f over t. Don't have to think more about it. This is maths and physics coming together and giving us some spectacular results. Average value of any function f over t, f dabba, will be equal to f dt ka integral divided by integral of dt. On similar lines, if I ask you what will be the f dabba, average value of f over x, x may be distance. How will I find the average value of any function over x? You can use some common sense. Maths and physics are all about common sense. How do I get the value of average value of f over x? Can anyone tell me? If you can't write, you can unmute yourself and tell me the answer. Raise your hands if anyone knows the answer. Then I'll ask you to unmute. You can unmute and give me your answer. Anyone would like to say? Anyone would like to comment on this? Anyone would like to tell me what will be the value of average function over x? And Surendra has given me the answer. Surendra, can you unmute yourself and tell me how do I get the average value of f over x? Unmute yourself, Surendra. Can you unmute yourself? You can't? Let's go and unmute and speak. You can't do it. Anyone else can do it. I hope I am audible and visible to all of you. You can see my hands. Tick, 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 tick. No one can unmute himself? Is a problem with the unmute button? I guess not. I have allowed anyone to unmute. I've allowed you to unmute. You should be able to unmute yourself. Yes, anyone? Okay, I think no one can do that. And as Surendra says average value of f over x, I will write it again like this. Average, it is over x. I can also write x here to make you understand. So here I will write t and here I will write x. So this is average value taken over time and this is average value taken over x. And how do I find it? It is simply integral of f dx divided by integral of dx. And this is how beautiful physics and maths are together. This is simply averaging function. We call it the averaging function. You can find the average of anything with this. You can find the average of anything with this. I'll give you a minute to write this down. Then we'll go back in past. Einstein says that you cannot go back in past because you cannot move faster than light, but you can create a shortcut in space and time. So we'll go back to past, to chapter 1, and see whether this average works or not. 1 minute. Note down this average value function. I hope everyone has written this average value function. Now let us put this average value function into some use. See whether it works or not. If it doesn't work, it's of no use. Let us see. We all recognize this. This is average speed. Average speed is total distance divided by total time. Just wait. Total distance is integral of dl. Total time is integral of dt. To find out the value of dl, I can write this dl, small distance in a very small time. I can write it as instantaneous speed into dt divided by integral of dt. And now you can see how did I get this average value of speed. Average value of speed is integral of v dt divided by integral of dt. Average value of speed over time, which is average speed, is integral of v dt, where v is your instantaneous speed, integral of v dt divided by integral of dt. Do we all understand this? Can I have some raised hand that we understand this? This is your chapter number 1, average velocity. Yes, Ravi, what is your doubt? Unmute yourself and ask your doubt. Average speed. V dabba is integral of v dt divided by integral of dt. It is the average value of function v. V is instantaneous speed. V dt divided by integral of dt. Do we understand this, everyone? I'll have to throw someone out. Don't see it here. Do we understand this, everyone? Can I have some raised hand that we understand this? Okay. Now, if I talk about V velocity ka dabba, V velocity ka dabba will be delta R, total change, total displacement divided by total time. That will be integral of dr divided by integral of dt, and I can simply write it as dr is v vector dt divided by dt, both integral. So you now understand that average velocity is the average function of this. So this average function works. This is maths and physics put together. And this works. Am I clear? If again I talk about average acceleration, it is total change in velocity divided by total time. I can write it as integral of v, integral of dv divided by integral of dt. It's easily written as integral of a dt divided by integral of dt. As you can see, this average value always works. I could have told you this on the first class, on the first day, but again, it would be difficult for you to understand. I hope you can understand it now. The average value function, as I always keep on telling you, there are lots of things for you to understand. There are lots of things for you to grasp. But I only tell you on a need to know basis. I only tell you when you need to know this. If you don't need to know this, I will not tell you. If you need to know this, I will tell you at the exact instant where you need to know this. From now onwards, wherever I call or tell you about average function, this is what you must recollect. Everywhere, wherever you find average, This is how averages are calculated. I'll give you a minute to note this down. If you have any doubts, please ask. Well, I hope you have noted this down, everyone, the average value function and how we can use this average value function for what we have learned some 3, 4, 5 months back. Okay. If you have understood this, then we'll note down some important points. And here are some points as taken from the notes that I have already shared with you. This is what you have to note down. Some important points would be there. I'll just go through them and we'll note this down. Power of a body is defined as the rate at which the body can do work. We all know this. Average power, P W is delta W by divided by delta T. We know this. Instantaneous power is dW by dt. The formula becomes F dot V. It is the scalar product of force with velocity. Do we all understand this? Can I have some raised hands and I can move forward? Okay, you all understand that. Great. What next? Here are some other points that you must always remember. The dimension of power is, you can find it out from F dot V, multiply the dimensions of F with velocity, or you know the dimension of work divided by the dimension of time. You will get the dimensions of power, ml square t minus 3. You cannot forget this. Units of work, units of power is watt or joule per second. In SI unit, in CGS it is ergs per second. Practical units are kilowatt, megawatt, horsepower. 1 watt is 1 joule per second, which is 10 raised to the power 7 ergs per second. You must know this. 1 horsepower is 746 watt. 1 megawatt is 10 raised to the power 6 watt. There's nothing here to explain. You have to note this down. I will give you a minute to do it. Yes, Viney, you can write. I will give you a minute to do this. I'll also be sharing this. This is already there with you. I've already shared this with you, so don't worry. I hope you have noted this down. Simple points. You can leave space, 2 or 3 lines. If you have not, the sheet is there with you. You can write it from the sheet. The other important points is point number 3. If work done by two bodies is same, remember power is instantaneous power. I am talking about dW. Oops, I have written dt. Let me make it as dW. dW divided by dt. If work is same, if you are doing same work, if you are doing it in less time, the power required will be more. So when I say I require a motor of higher power, that means I want to do some work in less time. More power means less time if the work is same. If you want to do the work in large more time, you can do the same work with a lesser power. That is, the body which performs the given work in lesser time has more power, and vice versa. This is pretty damn simple. This is common sense. I'll give you a minute to note this down. If work done is same, power is inversely proportional to time. Well, I hope you have noted this down. Let us move to the fourth point, and this is an important point that you must remember. Power is rate of doing work, work divided by time. So any unit of power, if I multiply it by a unit of time, power multiplied by time will give me the unit of work, or how much work is done, or how much energy is spent. Here it is important to know one term, which is kilowatt hour or kWh. Now this is the unit in which your bijli ka bill comes, your electricity bill comes in kilowatt hour. 1 unit of your electricity bill is equal to 1 kilowatt hour. How much is 1 kilowatt hour? 1 kilowatt is 10 raised to the power 3 watts. Multiply by it by the number of seconds in 1 hour. That will give you 1 kilowatt hour, and the value will be 3.6 into 10 raised to the power 6 joules. So if you are spending, or if your bijli ka bill tells you, electricity bill tells you 100 units you have consumed 3.6 into 10 raised to the power 6 multiplied by 100. That much energy you have used Kilowatt hour is the unit of energy that is used in your electricity bill. So that is why it is important for you to understand. And 1 kilowatt hour is 3.6 into 10 to the power 6 joules. I'll give you a minute to note this down. I hope everybody is noting it down. This sheet is already there with you, so you can notice down. The next thing that you must understand that the slope of work time graph, if I have work on y-axis and time on x-axis, remember power is dw by dt, slope of work time graph, dw by dt slope, that will be equal to tan of the angle theta, this angle theta. If I find the tan of this angle theta from the work time graph, the tan of this angle theta will give me the power. So power is the slope of work time graph. Do we understand this? Can I have some raise hand that we understand this, sir? Power is the slope of work time graph. Speed is the slope of distance time graph. Velocity is the slope of position time graph. Acceleration is the slope of velocity time graph. Same thing, same way to understand this. Slope of work time graph gives us instantaneous power. As simple as it gets. Give you a minute to note this down. We have one last point and that we'll cover. Draw the diagram and write power as the slope of work time graph. In place of power, if you write distance, the slope becomes speed or instantaneous speed. If you write velocity, it becomes, if you write displacement, it becomes velocity. If you write velocity, it becomes the slope of velocity time graph is acceleration. Everything is same as I've already told you. We are going back in time to chapter number 1 and trying to relate power with all these things that we have already done. That takes us to the last point that you must understand. We do the ulta of this. See, power is dw by dt. So dw becomes pdt. dw becomes pdt. dw is small amount of work done. We have already discussed this. So total work done will be integral of pdt, which is the area under pt graph. So if I have power plotted here, and it's a very important thing that you must understand, and time plotted here, and you have some graph like this, the area under this graph, will give me work done. So this is the ulta of this. Derivative of work done is power. Integral of pdt is work done. Derivative is the ulta of integral. Integral is the ulta of derivative. We have all done this in basic maths. This is all that we have for this class. I'll keep this screen on. I hope you have understood what is power, what is average power, what is instantaneous power, how are these related in terms of graphs as well. We have seen this. I hope you have understood this. In the next class, we'll be solving some numericals on this. As you can see, there are numericals here as well. So we'll start those numericals. If you can do the numericals on your own, I can tell you what all numericals you have to do. You have to do numericals starting from question number 64, which is there in your sheet. From question number 64 till question number 74. This one. So 64 to 74. Try to solve as many problems as you can. We'll be discussing some of these problems in the next class. From 64 to 74, I leave you with this screen of the theory part that we have done. Power is the slope of work time graph, and work done is the area under PT graph. I leave you here. If you have any doubts, I am always there. Please ask me. I hope you've enjoyed the class. If there is any doubt, ask me. Class from my side is over. It is dismissed. Take care and see you in the next class. Bye bye.